All right, Mr. Antonucci here, and we are on part four, calculate the test statistic and p-value for a test about the distribution of a categorical variable. So when we want to know um, if the distribution of a categorical variable is different than what we would expect, we have to use what's called a chi-square test statistic. It's a measure of how different the observed counts are from the expected counts relative to the expected counts. And the formula for the statistic is shown here. Some people pronounce it chi, some people pronounce it chi. I believe the correct pronunciation is chi. I'm probably going to say it both ways, so just bear with me. But it's the sum of the observed minus expected squared divided by the expected. So you do that for each of the counts, and then you add them all up, and that gives you your chi-squared test statistic. Now, again, make sure you use the observed and expected counts, not the observed and expected proportions when you're calculating the chi-squared test statistic. And so the AP exam tip here is that the formula sheet does contain the chi-square test statistic, and it's available on both sections. So for the multiple choice and free response sections for the AP Stats exam. But your part is you need to know when to use it and how to use it, and also how to interpret the results. So the next thing we need to talk about is something called the chi-square distribution. And it's a density curve that takes on only non-negative values and is skewed to the right. A particular chi-square distribution is specified by its degrees of freedom. So a couple important characteristics and things that we need to know. The sampling distribution of the chi-square test statistic is not a normal distribution. In other words, it doesn't have that bell shape. We can't talk about standard deviation in the terms that we normally have talked about it. The chi-squared distribution is right skewed and can never be negative. And the reason for that is this calculation up here that we performed is a value squared, essentially, which is never going to be negative. Okay. It has degrees of freedom equal to the number of categories minus one. So it's not the sample size as in the t-distribution, it's the number of categories, because remember we're talking about a categorical variable here. So in this graph down here, we have a couple examples of chi-square distributions with different degrees of freedom. With 1 degree freedom, it's in blue here. 4, it's in orange, and 8, it's in green here. And notice as the number of degrees of freedom increases, the peak gets lower, but you get more area in the tail. So a couple important characteristics. The mean of a particular chi-square distribution is equal to its degrees of freedom. If you have more than 2 degrees of freedom, the mode or peak of the chi-square density curve is at degrees of freedom minus 2. So if you look at this example here in green, the degrees of freedom is 8. Subtract 2, you get 6. That is where the peak is. Okay, this one for 4, subtract 2, you get 2. That's where the peak is right here in the orange one. So to get a p-value from a chi-square distribution, you can use either Table C or technology. Table C is usually found in the back of your book or in the appendix if you have a digital textbook, or if you're using the AP Stats formula sheet, it's going to be included in there. So let's look at an example here. What is the p-value for a chi-square of 9.8 and degrees of freedom of 6 minus 1, which is 5? So in other words, we calculated the chi-square test statistic and we got 9.8, and there were 6 categories, so our degrees of freedom is 5. We're going to show you how to do this on both Table C and the calculator. Now, Table C here, across the top, typically you'll have the tail probability, and then vertically, the first column will be the degrees of freedom. Okay, and so you find your degrees of freedom, similar to how we did it in the t-distribution. Since we have 5 here, there's actually a row there. And then you just go over on the row till you find 2 numbers for which your particular chi-square falls in between. So 9.8 is in between these two. So the p-value is going to be between 0.05 and 0.1. So using a calculator, I'll show you how to do that. So we got our calculator here. We turn it on, and then we're going to hit second variables to get to the distribution menu. And you scroll down to number 7. It's chi-squared CDF. We want the cumulative density function. So you hit enter. Then you put in your chi-square test statistic first, 9.8. And then you want to do comma like 1,000. If you remember from the distribution up here, wherever your chi-squared value is, 2, 4, 6, 8, 10, 12, whatever. Ours was 9.8 right about here. We're looking for the probability of getting that result or larger all the time. It's always going to be a right-sided or a right-tailed distribution. So you should be good always doing the chi-square, comma, 1,000, comma, degrees of freedom. Okay. And then you hit enter. And then we see we got a chi-square of 0.0811, which is between what we got from table C, which remember we said it was going to be between 0.05 and zero point 0.1. Okay, so the question we want to answer now is what conclusion would we make at a 5% significance level? Well, because our p-value of 0.0811 was greater than the null, or excuse me, greater than our significance level, we fail to reject the null. Now, failing to reject the null does not mean that the null hypothesis is necessarily true. All we can say is that our sample data did not provide convincing evidence, enough convincing evidence, to reject the null. So let's look at an example back to the NHL players. So we have our observed and expected counts here. Our sample size was 80, and we're going to calculate the chi-square test statistic, find the p-value, interpret it, and determine our conclusion. So here we go. Part A, we want to calculate the chi-square test statistic. So we're using this formula of observed minus expected squared divided by the expected. So for the first one, you would have 32 minus 20 squared divided by 20. The second one, you'd have 20 minus 20 squared divided by 20, and then so forth and so on. You figure out those values, and then you add them up. So our chi-square value for this one is 11.2. Okay. Now, to find the p-value, you need the degrees of freedom. And remember, it's not the sample size, it's the number of categories. Okay. Degrees of freedom, 4 minus 1, that gives us 3. And then using technology, if we did 11.2, comma 1,000, comma degrees of freedom 3, you get 0.0107. Okay, so this is good to write it like this. Make sure you have the lower, upper, and DF in your calculator kind of font thing here if when you're showing the work. If you use table C, to get the particular p-value, 0.0107 is going to be between 0.01, or excuse me, 0.025 and 0.01. If you look at our distribution, this is the chi-square distribution with 3 degrees of freedom. Okay, notice the peak is at 1, which is 2 less than the degrees of freedom. 11.2 is right here. So if we're looking for the probability of getting 11.2 or greater, it's a very small area here. Part C, we want to interpret what that means. Okay, so we're going to use the technology value of 0.0107. So assuming that the population proportion of NHL players born in each quarter are all the same, there is a 0.0107 probability of getting a distribution of birthdays in a random sample of size 80 this different or more different than the hypothesized distribution by chance alone. Okay, now you look at the structure of this. We assume the null is true. We are in context. We have the specific p-value. We say the size of the sample, and we talk about it in terms of the result, the distribution being this different or more different than the hypothesized distribution by chance alone. Okay, and then part D was to state our conclusion. So because the p-value of 0.0107 is less than 0.05, we should reject the null. Remember, there's two sentences when you state your conclusion. You make a determination based on the p-value, and you either reject or fail to reject the null. And then the second sentence is say what the conclusion is in context. There is convincing evidence that the birthdays of NHL hockey players are not uniformly distributed across the 4 quarters of the year. Okay. Now, notice we're not saying that we've proved it. We're not making like a definite statement. We're saying we have convincing evidence. We're also not specifying what the distribution is or that our sample distribution is what the population distribution is. We're just saying that we have convincing evidence that the birthdays are not uniformly distributed across the 4 quarters of the year. Now, you can use your calculator to compute the chi-square test statistic and p-value directly from the observed and expected counts. Now, in the TI-84, you can do this by plugging in the observed and expected counts into your list. Notice you have 32, 20, 16, 12. That corresponds to the observed counts here, and then the expected counts here as well. And remember, if you get a decimal value for the expected count, that's fine. Don't round it. Put that decimal value in here. Then you want to press Stat and go over to Tests, and then scroll down to chi-squared GOF, stands for goodness of fit, test. When that screen appears, you're going to do the observed in L1, expected in L2, degrees of freedom. Don't worry about the color, and then hit enter. And it's going to tell you the chi-square value, the p-value, degrees of freedom, and this stands for contribution. We'll talk about what that means in a second. Okay, so for our AP exam tip, if you're going to use the calculator to carry out the mechanics of a significance test on the AP Stats exam, which I recommend you do, there is a risk involved. If you use the calculator answer but don't show any work, and one or more of your values are incorrect, you'll stand to lose credit for the do step. So make sure to include the chi-square test statistic, degrees of freedom, and p-value in the do step. In other words, write all of this stuff down right here, the chi-square, p-value, degrees of freedom. You don't have to write the contribution down, but make sure you write those three values down in the do step and continue the rest of the process. Make sure you do the whole state, the plan, this is talking about the do, and then the conclude. So since using the calculator generally is going to give us more accurate results than the values that you would do if you did it by hand and doing some rounding when you do your calculations, we're going to typically use the values from a calculator when we report the results there. All right. Well, that's it for this one. Hope that was helpful to you guys. Take care.